So we are on page 35. Page 35, 35. So what you'll notice here is that you have an element, a compound, and you have a compound, page 35. And an element. What kind of reaction does that look like? What type of reaction? Single replacement. But if you try and do this as single replacement with water written as H2O, it's difficult. What could we do with our H2O instead? We could rewrite it as HOH. And once we've done that, we can treat the OH as a single unit. Just like we were doing with the other polyatomic ions, we can treat them as a single unit. So we would have Li, H, and OH. We would have Li, H, and OH. So the Li looks, oh, there's supposed to be an I there. Let's see. We have one Li, one Li, one H, two H's, and one OH, one OH. So let us fix our hydrogen by multiplying this by 2. You'll notice that I'm not including, oh, hang on. Oh, no, we're good. Yeah, if I multiply this by 2, then we have 2 hydrogens, but we are also going to have 2 OHs, which means now we need to fix our OH. So let's put a 2 here. That will fix the OH. And then we need to say, oh, that also changed my Li. And so then we need to put a 2 here so that everybody is good. Is good? So if you're having trouble, you can change an H2O into an HOH and treat the OH as a group. Works well for single replacement. It also works well for, what kind of a reaction do we have here? This is on page 36. I think it's on page 36. Yes. What type of reaction is this? Yeah, we have hydrogen, which tells us that we have an acid. And we have hydroxide, which tells us that we have a base. If we have an acid plus a base, what kind of reaction is that? Neutralization. What are the products when we have an acid plus a base? An acid plus a base gives water plus a salt. And a salt is just an ionic compound, okay? Can anyone tell me what this also looks like? Because neutralization is just a special type of what other kind of reaction? Neutralization is a special type of, I'll let you guys think that through. Is it a special type of decomposition, synthesis, single replacement, or double replacement? Double replacement, okay? And it's a special type when you have an acid and a base as your reactants. Now, easiest way to balance these, if you have any trouble whatsoever, is to take your water, and what would you do with your water? Instead of writing it H2O, you could write it as HOH. So let's do that here. Okay, so we've got it written as HOH, and I've written down all the numbers for us. Now we can apply one of the rules that we learned last day, which is to balance ions in the most complex compound first. So who is our most complex compound out of those 4 compounds? Fe2CO33. There's lots of subscripts, right? In that one, lots of subscripts. So that would be this one right here. So let's balance our Fe. We have 2 Fe's. So let's put a 2 here. That changes Fe to a 2, but it also changes hydroxide. How many hydroxides do we have now? We have 2 times 3 is 6 hydroxides. Excellent. So we've done the iron. Now we're going to do the CO3. We have 3 on the right. We have only 1 on the left. Remember, if there's no brackets, how many do we have? There's no brackets. Those don't exist. So how many do we have? Just 1. Okay. Whoops. So we're going to multiply this by 3. That gives us 3 carbonates. And now it has also changed our hydrogen. So now we have 3 times 2 is 6 hydrogens. Okay. And so now the carbonate is good. The iron is good. Now we need to balance the H and the OH. Well, what if we just put a 6 in front of the water? That gives us 6 hydrogen and 6 hydroxide. Okay, so follow those rules, and balancing neutralization becomes really easy. A lot of people get stuck because they try and keep the HOH like as H2O. There is another way to balance acid bases if you like. I'll just mention it over here. The number of hydrogen, hydroxide, and H2O must all be the same. This is just an extra little bonus method. And this one does not require you to break H2O into HOH. Okay? Hydrogen and hydroxide and water all have to be the same number. So if we were to go back here and just look at this one. Okay. Hydrogen, I have 2 of them. Hydroxide, I have 3 of them. And water, I have just 1 water. 2, 3, and 1. Now, if I want the same number of hydrogen and hydroxide, if I have a 2 and a 3, my lowest common multiple is 6. So I'm going to put a 3 here. That gives me 6 hydrogens. I put a 2 here. That gives me 6 hydroxides. How many waters will I need? 6. Done. So that's the other way of doing acids and bases, is just to say, I need the same number of hydrogen and hydroxide. Usually you can find that with the lowest common multiple, and then you just say, I need the same number of waters. Done. Whew. But if that's too hard to remember, you can just change water into HOH, and that will work for you nicely. Okay, so there's a little bit of practice here. You guys want to take a couple minutes and do those ones? And if you've already worked ahead, you could try looking at balancing combustion on your own if you've already worked ahead. I don't know, you could try looking at decomposition. Anyway, help yourself to whatever you like. Yes. Yes. Oh, yeah.
I think it's number 14.
I'm just going to hit the light.
So 14 is, I'm looking at the answer sheet and I said to add a 2 here, right? But I didn't think I needed to add a 2. Oh.
Number 14, number 1, it should be just 1 AL2.
Okay.
SO43, yeah. Yeah, if you guys missed it last day, number 14, the answer key is wrong. Okay, I'll put it back up here. Hi. Yeah, sure. Yeah. There you go. And do you need a periodic table and table of ions, or are you good? You've got it good?
Yeah.
Okay. I accidentally didn't double side it, so it's stapled together. But it's all good. It's just like normal, but
okay.
Yeah.
Sure. Yeah.
It's not actually any longer. So for right now, we are doing page, let's see, 34, no, not 34, page 36 and 37. And if you're done those, you can try the combustion ones, take a look at it, see if it makes sense to you. And if it doesn't make sense, don't worry, we'll go over it. Okay, sure, no worries.
Do you think we could have a quiz on balancing on Monday?
Well, let's see how we do with balancing combustion for starters. All right, we are now on page 38. Okay. Combustion. In a combustion reaction, you're going to have a carbon. You are going to have a hydrogen, and you might also have an oxygen. Oxygen, maybe, maybe not. And your carbon will have some subscript, your hydrogen will have a subscript, and your oxygen, if there is one, will have a subscript of some kind. So that is one of the components. The oxygen is optional. So you either have C something, H something, or you have CHO something, okay? Who is the other reactant in combustion? What do you need in order for fire to burn? You need oxygen. Yes, because combustion is just burning. Combustion is burning. Who are the products of combustion? And this one is actually interesting because you know your body burns fuel, right? Energy in your body. You actually exhale products of combustion. You're not burning things in the same way. Your body has a more controlled way of doing it so you don't catch on fire, which is good. But you actually, when you inhale, you are breathing in oxygen, which is going to react with the sugar in your body. Sugar is made of CHO, right? So you're actually reacting in your body oxygen with CHO, and you end up breathing out the two products. What do you breathe out? What's one thing you breathe out? CO2. And the other one is H2O. So if you're like, oh, when I breathe on a mirror or on a piece of glass on a winter day, you can see the water condense. Okay, so you breathe out CO2 and H2O. And those are the same products of burning, and they're the same products of what we call cellular respiration. If you're taking biology, that's what that process, that more controlled burn is in your body, so you don't have to catch on fire. So, how to go about this? You're going to do them in a specific order. You're going to do it in the order C and then H and then O. Now, this doesn't break any of the other rules we've been doing because I've always said maybe balance hydrogen and oxygen last, right? That's another tip. So if you're having trouble with something, you can try balancing hydrogen and oxygen last. Also, you're going to balance lone elements last. What does that mean? Yeah, if they're standing alone. No other element paired with it, not in a compound, just by itself. Who is our lone element in this reaction? Oxygen is our lone element. So it makes sense that we're going to balance it last, right? So it goes, and you can remember this, it's Cho, which sounds like a person's name, right? Here's the tricky bit. I'll show you another method to do it as well, and you can decide which one you like. You may have to use a fractional coefficient on O2. All right? If you use a fraction, then you need to multiply everything later. Let's start by looking at a single oxygen molecule. How many O's are in oxygen? 2. There's 2 O's. What could I do to that molecule to get 1 O? I could like break it in half, right? So if I split it in half, this right here, that's a half of an O2. And that right there, that is a half of an O2. So what this is going to allow us to do is it's going to allow us to have an odd number of oxygens by just using O2, okay? So you can say one oxygen atom is a half of an O2. But let's say you needed 3 oxygen atoms. You don't want 1 oxygen atom, you want 3 of them. Well, this is a half of an O2, this is a half of an O2, and this is a half of an O2. How many halves is that all together? A half plus a half plus a half is 3 halves of O2 is equal to 3 O atoms. Yeah? So that's going to allow us to do 3. What if we wanted to do 5 O atoms? Well, that would be a half of an O2 plus 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 a, oh, it's flickering on me again. Okay, plus a half of an O2. How many halves is that? 1, 2, 3, 4, 5 halves. Now we have 5 halves of O2 is equal to 5 oxygen atoms. And you can do that for anything. What if you wanted 17 O atoms? How could you write that as a fraction of O2? 17 over 2, 17 halves of O2. If you wanted 23 O atoms, you could write 23 over 2 O2s. Okay, so this is going to come in handy. It'll make balancing these things a lot easier. Oh, look, we've got the 5 example here. We've got 7, we've got 9, we've got 11, we've got 13. Oh my goodness. Now, let's try the following here. We have Ca plus O2 gives CaO. Now, I know you could balance this without halves, but we're trying it out on a really simple example. Okay, so we're just trying this out here. I have Ca, I have 1, O, I have 2, Ca, I have 1, and O, I have 1. What I could do if I wanted to is I could say I don't want to have 2 oxygens, I want to have 1 oxygen. So I'm going to put half here, and that gives me 1 oxygen. So that's actually all balanced now, right? I've got 1, 1, 1, 1. We don't usually like to leave it like that, if we have a half, then what we do is we take this whole thing and we multiply it by 2. So we're going to end up with then 2, because there's a 1 here, remember, that we don't write, 2Ca plus, what's 2 times a half? 1. 2 times a half is 1 O2 gives 2 times, and there's a 1 here, 2 times 1 is 2 CaO. Like I said, you probably would not need to do that. You could just guess and check for that one, is fine, okay? But I did want it to, like, you to see how it worked in a really easy example. Let's try this one here on our next page, okay? Remember, we're going to balance it in the order C, then H, then O. So let's start by balancing our carbon. Over here we have 2 carbon, so we need to put a 2 here. That changes the carbon, but it also changes the O. And I have 2 times 2 is 4, but I also have 1 over here, so I have not just 4, but I have 5. So that's 5 oxygens. So I've done the carbon. Now I'm going to do hydrogen. I have 6 hydrogen here, so if I multiply this by 3, that gives me 6 hydrogen here, but that also changed the oxygen. So now I have 2 times 2 is 4, plus another 3 is, how many oxygens in total now? 7. Okay. Now, wouldn't it be nice, because this is, carbon's good, hydrogen's good. What can I do with that oxygen over here to get 7 oxygen atoms? I can do 7 over 2. Not pretty? Did you guys catch how that worked? Don't worry, we're going to do more examples if you didn't catch how it worked. Okay? Because if I have 7 halves of O2, remember what that looks like? Here's a half of an O2. 1, 2, 3, 4, 5, 6, 7. So I have 7 halves of an O2. That gives me 7 O atoms. Okay? And once I've got that, I'm good to go. I just need to then multiply the whole thing by 2 so that I don't have a fraction anymore. Okay, so we actually do that down here. Oh, look, I drew them out. How lovely. So we're going to take this whole thing and we're going to multiply by 2. So what's the coefficient now going to be here? It's going to be a 2. This is going to become a 7. This is going to become a 4, and this is going to become a 6. And you don't even have to rewrite the equation. You can just cross them out and like write them up top, and that's all good. Okay, so there we have it. Okay, let's see. I'm going to try this one. I'm not sure if I've actually got it correct here. So I'm going to try it over on the right. We have C19. This one's horrible. H17, NO3 plus O2 gives CO2 plus H2O plus NO2. That's an extra product, okay? If you have an N, you'll get NO2. If you have an S, you'll get SO2. Okay, so don't worry about that too much. I just put it in here because we wanted a big, horrible example to show you that this could be done. This can be done. We can do it. Hopefully I can do it. I've done it wrong twice just because it's easy to make a mistake. But let's see if I can do it today. And let's see if I've done it right in the book. I may not have. We'll find out. All right, carbon. Starting with carbon, we have 19, 17 hydrogen, 1 nitrogen, and 5 oxygen. 5. 1 carbon, 2 hydrogen, 1 nitrogen, and 2 plus 1 plus 2 is 5. Oh, that should say oxygen. Oops. See, already I've made a mistake. This does not bode well, but let's keep going. All right, carbon first. We need 19. So that changes my carbon to 19, but it also changes my oxygen. Now I have 19 times 2 is 38, but I also have another 1 and another 2. And so that gives me 38, 39, 41, 42. 42 oxygens. Is it 41? Oh yeah, it's 41. I can't count. See, I was already ready to make a mistake. Oh, I'm going to turn that back on. There we go. Okay. So we have 41 oxygen. Not worried about oxygen yet. Let's just keep going. Hydrogen. We have 17 hydrogen here, and we have 2 hydrogen here. I have an odd and an even number. What will I do? I have to find the lowest common multiple. So I have 17 and I have 2. So 2 times 17 is 34. So I'm going to multiply this one by 2 and this one by 17. Whew. Did I do something wrong here? Oh, yes, I did. This should have been the 2 and this should have been the 7. I was like 17 times 19. That looks terrible. That's better. 17. There we go. Hang on. That's a plus. That's a hydrogen. And that's a 17. There we go. You are never going to have to balance one this gross, but I'm just doing it to prove to you that it can be done. So now we don't have 19 carbons anymore. Now we have 38. Okay. We don't have 17 hydrogens anymore. We have 34. We now have 2 nitrogens. And the oxygen is in 2 places, so we have 6 plus 2 is 8. So let's change this one to a 38 because we're going to go back and fix our carbon now. Okay, so that gives us 38 CO2s, but it also gives us 38 times 2. 38 plus 38 is 16, carry the 1, 76 oxygens plus another 17. So I have 76 oxygens plus another 17 oxygens plus another, oh, and I should actually fix my N while I'm at it. Should I fix my N? Let's fix my N because I've got two N's over here. Let's make a 2 here. Might as well do that while we're here. And so it's 76 and 17 and 4. Is that 97? So I have now 97 oxygens. Do I put a 97 halves here? Probably not, because I already have, you have to take into account the fact that we already have 6 oxygens there. So instead of 97, we need 97 minus 6, which is 91 oxygens. So we're going to instead put 91 over 2. We will never do this again, okay? You are never going to have to do one this gross. It's not hard, it's tedious, exactly. And I have, did you see how many mistakes I made there just like going through, like, yeah. I'm glad I have all of you checking me out, right? Like it's like checking the answer and going, oh, there we need you've added wrong, or oh, you've multiplied wrong, or oh, you wrote an H instead of an O. It's good that you guys are the second set of eyes and the actually 32nd set of eyes, okay? So that's exhausting. And then at the end of that all, we would have to multiply it all by 2. So we would end up with 4 and then 80, 182, and then, oh no, this would be 91. Yeah, because I'm just stupid. And then 38 times 2 is 76, and 34, and 2, and never again do you have to do that. Oh, 2 times 2 is 4. See? Oh, bleh, horrible, right? Oh. However, let's see if I got it right. Oh, I think my answer key is wrong. Yeah, I did. No, this is wrong. So this should be a 91. 91. 91. 91. 97. Anyway, don't worry about it. You can just be like, okay, do you want to try some of these, or do you want to do one again with me, like an easier one? Or are you just ready to go? We'll do one easy one together. Okay, so let's do number 3. Okay? Number 3, we have 3 carbons, 8 hydrogens, 2 oxygens. We have 1 carbon, 2 hydrogens, 1 oxygen. So let's balance who first? Carbon. Carbon first. Who comes next? Hydrogen. And who comes last? Oxygen. So let's do carbon. 3. Bam. 3 carbons. And now we have, why did I write 1 oxygen? We had 1, 2, 3 oxygen to start with, but now we have 3 times 2 is 6 plus 1 is 7. Much nicer, yes? No 97s. 7 is good enough. Hydrogen. We have 8 hydrogen on the left and 2 hydrogen on the right. So we need to multiply the water by 4. That changes hydrogen to 8, but it also changes our oxygen to 3 times 2 is 6 plus 4 is 10. Oh, this one we don't even need a half. Look at that. What if I had needed to, like, let's say this was 11 instead, what would I do? I would put 11 halves, and then I would multiply everything by 2. But it's not, so it's just 10, so I can just put a 5 and say, oh, that's 10, and then there we go. Is good? Okay. Give these ones a try. Have fun with them. I think that's going to be it for today, probably, because these ones can be a bit of a chore, and I've provided a lot of examples because they do need a lot of practice. Was one of the answers wrong? No? Okay. You just did them? Okay, okay, cool. So yeah, so for homework, finish pages. Let's see. Hi.
I don't understand this question because how many atoms are there in C? This is the formula, right?
Mm-hmm.
Atoms of what? What are
Atoms, like all atoms together, so carbon and hydrogen, both of them. So just count them up in total. So you'd be like, I have this many carbon, I have this many hydrogen, how many in total?
Okay, okay, thank you.
Yeah? You're good, you're good, you're good. Don't forget, if you want to redo your mold quiz, I would like that to happen sooner than later. And it is one of those things where it's just a quiz, right? So if you're like, that's fine. If you're not taking chemistry 12, you can probably let it go. If you are taking chemistry 12, it would behoove you, it would be good for you if you did not do well to retake it so that you learn the material because you will be using moles in chemistry 12. Okay, so if you did well or if you did well enough, then I would say just leave it. If you did not so good, but you don't care because you're not taking Chem 12 and you're still going to pass, that's all fine. But if you didn't do well and you are planning on taking Chem 12, then please make sure that you retake it, come in. I can give you a little bit of help with stuff so that you are set for next year. How many people are thinking of taking Chem 12 next year? Quite a number of you. Okay. That'll probably be me. Well, me or Mr. Weinberg. Ms. Wu and I kind of alternate because we do the enriched and AP, and so when we're doing the enriched, we do 11, and we're doing AP.
Well, I don't know this. My lowest test was oh yeah. We need to go deeper. Yeah, we're like confused. We can't remember. We have no idea. What's the grinding?